Okay, what we're covering for today, we are covering two-step equations. That means how to solve two-step linear equations. Subtract. That's one. Actually, that's probably like 5 today, but it's 1 on this video. We're covering two-step linear equations and how to solve them when they are in just a single variable term, meaning that you are just solving for x, or you are just solving for y or w, whatever your variable is, it's just a single term. So most common two-step equations that we see look like this format, where you have ax plus or minus a b value is equal to a c value. Okay, where a, b, and c happen to be real numbers. So this is usually the setup that we have. There are other ways to set it up as well, but this is the most typical that we're going to be dealing with our linear equations. So what I want you guys to do is learn how to solve them when they're in this format. Two-step means that you have two operations that you will be performing. You will either be adding or subtracting as one of your operations, and then you will either be multiplying or dividing as your second operation. We always do our addition and subtraction first as our inverse because it's working backwards through those order of operations. If you think of the order of operations, it's kind of like a way to locate something to get to an answer when you're working something out. But if something is missing, think about when you misplace something at home. If it's your keys or your book or your phone and you don't have any other way to find it, no technology way to find it, what do? Retrace your steps. When you've lost something, if it's a book, you can't call it. You know, if you've misplaced your keys, you can't call them. And if you've misplaced your phone and nobody else is at home and you don't have any other device to hit to look for it, you got to retrace your steps. So when we're solving, it's like we're retracing our steps to find the item that's missing, the item that we lost, which is our variable. So our steps are usually those order of operations. We usually do multiplication and division before we do addition and subtraction. But when we're retracing our steps, we work backwards. We do addition and subtraction first, then we move into multiplication and division. Then we get into exponents, and we finish off with any parentheses. Okay, so that would be our order of operations going backwards when we're solving. So for here, what we're focusing on is the idea of adding and subtracting to our constant. So this is those reminders. Remember, I told you before, there are vocabulary terms that you are never going to be able to get rid of. The constant is one of those vocabulary terms. Your constant is located here, that minus 11. That minus 11 is considered to be your constant. Shh. It is the number that is isolated completely by itself. It is not attached to your variable. Who can raise their hand and remind me, what do we call the 2? Raise your hand and remind me. Daphne? A coefficient. I'm just going to abbreviate it. The 2 is what we call our coefficient. Askia and subtract. Again, stop fighting over stuff. Stop fighting over stuff. The x is what we call our variable. So when we are working through these problems, we need to make sure that we're going through it backwards. So the very first thing that we're going to do is get rid of the constant. So if I'm taking a look at this problem as 2x minus 11 is equal to 5, I need to get rid of my constant first. So I'm going to put a box around my constant. And right now my constant says minus 11, doesn't it? So if I cover everything else up, I'm going to do the opposite. What is the opposite of minus 11? Addition. So instead of subtracting 11, I'm going to add 11. Now, the reason I put a box around it is because I know this information is now going to go ahead and get canceled out. But I have to add 11 somewhere else. Where else am I going to add the 11 to? Which one of those values am I adding an 11 to? The 5. Okay, I'm going to add 11 over to where the 5 is. Remember when we say we do this to both sides? Your sides is considered to be things like that equal sign. If you want to put up a little invisible wall here so that you know that this is one side and this is the other side, by all means do so. When you do that, what you're remaining with is this 2x, because that did not get canceled out, equals, and then what's 5 plus 11? 16. So we now have the equation 2x is equal to 16. I'm going to go ahead and write that down here in my next step, because my next step is to solve this equation. The 2x is equal to 16. And it's easy to do that because that's what step 2 says. You're doing the inverse operation by either multiplying or dividing in order to solve. So if we see 2x is equal to 16, what is the inverse operation, the opposite operation, Hayden? 16 divided by 2. Or better yet, saying that I'm going to divide by 2 on both sides. I'm dividing 2 by 2 so that the x is all isolated. I'm dividing 16 by 2. And I'll get x is equal to 8. Now here's the wonderful thing, guys. I've told you this before. I don't think you guys quite listened to me, but maybe you'll listen now. There's a wonderful way to be able to check this. So off to the side, I want you to write check. Your problem originally was 2x minus 11 is equal to 5. I can check that I got the correct answer by replacing my x with the value that I just solved for. So instead of x, I'm going to replace it with a what? What did I just say x was equal to? 8. I'm going to replace it with an 8, and I'm going to see if this works. What is 2 times 8 minus 11? Type it into your calculator. You can type it all in at once. Take those calculators. Do 2 times 8 minus 11, and what do you get? 5. Is that what we wanted? Yes. It says it's supposed to equal 5. It did equal 5. That means we got the correct answer. If you type the solution that you got into your problem and it does not come out to what it's supposed to equal, then you did something wrong. So you don't want to keep that as your answer. You want to go and figure out what you did wrong. This is the wonderful thing about equations. They are self-checking if you just take the time to do so. Okay, let's take a look at problem number 1. I just told you what the first step is always going to be in a situation like this, in this kind of setup. The first step is always to do addition or subtraction to our constant. So I want to identify my constant first. What number up here is my constant? Muhammad? 3. I'm going to include the sign that's in front of it so that I know I need to do the opposite of that. So what's the opposite going to be? Minus 3. So we're going to subtract 3 from both sides. By doing so, I'm going to get 2x is now equal to 20. 2x is equal to 20. What do I need to do now? Am I going to multiply or divide? Divide. What am I dividing both sides by? 2. Cancel those 2's out. X is now by itself. And what is 20 divided by 2? 10. Okay, again, I can plug this in. I can do 2 times 10 plus 3. When I do 2 times 10, I get 20. Plus 3, I get 23. So we're good. First thing I need to do, identify my constant. What's my constant? The constant is 5. Thank you. The constant is 5. I'm going to include the operation in front of it. What's the inverse going to be here? Subtraction. We're subtracting 5 from both sides. Subtract 5 on both sides. So we're going to get x over 2 is now equal to negative 7. Am I going to multiply or divide?
Multiply.
Multiply. What am I multiplying both sides by? 2. Not x over 2, just 2. Multiplying by both sides by 2. That gets x by itself. What's negative 7 times 2? Negative 14. Okay, again, if I check it, if I do negative 14 divided by 2, and then I add 5, it will give me negative 2. Take a moment, get that copy down, then flip it on over to the back. Very good. All right, let's take a look at problem number 3. Actually, you know what? I want to skip. Let's go down to problem number 5. Go down to problem number 5. The first thing I want to do with problem number 5 is make note that right now I don't have a variable on the left side. Here's what I mean. If we look at all the problems that we were doing before, and we look at the equal sign, here's my equal sign. My x is on the left side of the equal sign. For number 2, my x is on the left side of the equal sign. For problem 3, the variable is on the left side. Same thing for problem 4, the variable is on the left side of the equal sign. But problem 5, the variable is on the right side. I don't like that. I don't like having the variable on the right side, and there's a reason for it. When we get into inequalities, you always need to have the variable on the left. So I want you guys to get used to rewriting. You are going to rewrite whenever you see an equation where the variable is on the right side of the equal sign, you're just going to rewrite it. You're going to take this whole thing and go, okay, 5 minus 3y equals 20. All I did was flip-flop it. That's it. Destiny, turn around. Stop talking to him. So I'm just rewriting it so that my variable is on the left side. That gets you set up and ready for when we get into inequalities next. You'll get used to always doing it, and it won't be that big of a deal. Okay, so for problem number 5, first thing I want to do is I want to identify my constant. What number up here is my constant? The 5. The 5 is my constant. What inverse operation am I going to do? Wrong. If I add 5, what's 5 plus 5?
10.
So did I get rid of the number? I just created a new one. To get rid of it, I need to get it to being a zeroed value. I didn't create a 0 value, I just created another number 10. I just created a different constant. So a lot of times people see that minus sign and they immediately think, ooh, I'm going to add. But where does that minus sign belong? It belongs to which value? The 3. The minus sign belongs to the 3, not to the 5. What sign technically is in front of that 5? There is one. It's an invisible sign. It's an addition sign or a plus sign because it is a positive 5. Technically, there is a value in front of that constant. It is a positive 5 that's written in front of here. So what is the opposite of that? Minus 5. So we're going to subtract 5 from both sides. Those 5s are going to cancel out. And here's where the next big mistake comes from. People bringing down their answer, they always want to bring down the 3y, and they forget to bring down that minus sign. But that minus sign now acts like a negative. So now instead of minus 3y, it's a negative 3y. And that's equal to 15. From here, we now divide. Here's another mistake everybody makes. They think that they have to divide by the opposite of the value. Multiplication and division are not opposites of values. They're just opposite operations. So please keep that in mind, that when you multiply or divide, you are multiplying or dividing by the entire value. That includes the sign. If I only did -3 divided by 3, I would be left with a -1, not a +1. So here we would get y is equal to -5. But again, you would find out you made a mistake if you forgot to divide by your negative and you put a 5 in there instead of a -5. You would find out you made a mistake. Because if you put a +5 into here, then you'd wind up getting -10 as your answer instead of 20. So checking your work is always a good thing to do. I want to take a look at problem number 7. Because number 7, again, it's a similar practice to what we just did here. So let's go ahead and scroll down to number 7. I don't have to rewrite it because the variable is on the left side already. But I do need to identify my constant. What is my constant? +5. And good, thank you, Malaysia, for saying +5. So that way I know to put a plus sign in front of it. So what is the opposite of +5? -5 or -5. So we're going to subtract 5 from both sides. And those will cancel out. We're then going to bring down that -7x. And it's going to be equal to 14. Our last step would then be to divide both sides by -7. We would get x is equal to -2. We're going to continue the notes tomorrow. Do not lose these.